Hello once again, my name is Andrew Dunkley and welcome to another edition of Space Nuts. Coming up on this episode, black holes. Well, we know they exist. We don't know a heck of a lot about them. We've only imaged two of them, in fact, but they have found a new one. It's actually a new class of black hole and it's enormous and it's just over there. We'll also be talking about the Last Universal Common Ancestor. It's older than we thought, and it is basically what made life as we know it come into existence. And space junk in the news again for all the wrong reasons. That's coming up on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9, ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And I have to be very careful about where I'm pointing when I'm talking about the discovery of a black hole, because I was pointing straight at my wife. Anyway, joining us as well to discuss all that, Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew.
I'm in trouble already.
You could point to it, actually, because this black hole is one that is in our southern sky.
Yeah.
I think it's probably circumpolar, which means it always goes around the sky. It might not be quite circumpolar, but it's getting on that way.
Okay. Well, we'll talk about that and all those other things. First of all, though, how are you and how have you been?
Well, thanks. Recovered from our Outback tour a couple of weeks ago. That's still fresh in our memory, though, some of the things we saw, the extraordinary.
Which reminds me, Fred, we have a note from Tracy. You talked about Tracy the other day, who won the auction.
Yes, she did.
For your book. She sent us a note. Hi, Fred and Andrew. Tracy Hill here. Thanks for the shout out. Have clipped the segment to put on my Facebook page for family and friends to listen. It was a great night and have just started the book. I will submit my questions soon. So there you are.
Well, that's paradoxical, because that book is actually, the one she got was Where's Uranus Upside Down, which is all questions. The whole book's questions. So she's got plenty to go from. Fortunately, I could just read out the answers.
Yes. But you know what we've discovered with discoveries in space is they always throw up more questions, and questions tend to throw up follow-up questions. It's just the way of humanity, isn't it? We've always got questions.
Indeed it is. We're full of questions. Every answer to a question tends to spawn a new question in the world of astronomy and space science.
Yes. I expect we'll get a shout-out from Tracy after we gave her a shout-out after she got the shout-out. So this could keep going around and around. Let's get onto it. Our first topic is that of a black hole. This is a recently categorised variety of black hole because it is what they call intermediate. And that was one we talked about probably a couple of years ago when I think the way it went, we were talking about the different sizes of black holes one episode, and we said, look, they're either small or massive, but we can't find anything in between. And honestly, within a month, I think they found one.
Yes.
And now they've found another one.
Yeah. And this one's really significant because I think this is a very, pretty solid discovery of intermediate, what's called an intermediate mass black hole. Let's just go through the details, because black holes do come in basically two flavors. The stellar mass black holes, which, as the name suggests, are about the mass of a star. In fact, they're the mass of a massive star, usually 10, 20 times the mass of our sun. So our sun won't turn into a black hole. But when one of these massive stars ends its life, runs out of fuel, the core collapses, and nothing will stop the collapse, and you get a black hole at the end of it. And we recognize those. There are several in our galaxy. We recognize them by the effect on their surroundings. They're usually swallowing up stuff and emitting X-rays. The other end of the scale is the supermassive black holes, which are millions or billions of times the mass of the sun. And we think there's one of these at the middle of every galaxy. We've talked about them a lot. There is certainly one at the middle of our galaxy. It's about 4 million times the mass of the sun in the constellation of Sagittarius at a distance of about 25,000 light years. So quite a long way off. Not doing much at the moment, although it does occasionally swallow a gas cloud and get bright in the infrared and radio spectra, but is visible at optical wavelengths. That's to say, the wavelength of visible light. Astrophysicists think that the supermassive black holes get that way by lots of black holes coming together. In other words, over time, they accrete other black holes. So they basically, gobble up other black holes, and you get this thing that's growing up to millions of times the mass of the sun or more. That's been thrown a little bit into question recently by the fact that we see some of these supermassive black holes very early in the history of the universe. That's results that have come from the James Webb Space Telescope. But we still have this gap in the middle. Why don't we see anything that's on its way to becoming a supermassive black hole, for example? Why don't we see something that's bigger than thousands of times a stellar mass black hole? And these are the things we would call intermediate black holes with a mass in the region of thousands to tens of thousands of the mass of the sun. So where would you look to try and find these? What you might look for is things that we think are the remnants of a galaxy that's been stopped from evolving. So if you imagine a young galaxy with its stars, maybe a bit of spiral arms and things of that sort coming on, and a nucleus of old stars, and then you suck it into another galaxy, what you might get left with is the sort of nucleus of stars from the galaxy that's been swallowed up, plus its black hole that would be in the middle of that. And because what you've done is you've taken this galaxy out of the evolution stakes, in other words, you've stopped it growing, maybe the black hole would stop growing as well. And so this might be a way of finding these intermediate mass black holes. And the scenario that I've just elaborated is exactly what we think is the mechanism by which globular clusters are formed. These are clusters of stars that have been known for, many hundreds of years. In fact, it was William Herschel who gave them the name globular clusters because they look globular. And they're swarms of stars, up to 1 million stars in the biggest ones, and very, very tightly packed together, Andrew. So the stars are all not exactly bumping into one another, but very, very close. And the thinking is that these are the nuclei, the centers of galaxies that were stripped off, that had their outer regions stripped off because they were being swallowed up by another galaxy, in this case our own Milky Way galaxy. And we've got something like, it's probably up to about 200 globular clusters that swarm around the Milky Way galaxy. And the thinking is that they are the remnants of baby galaxies that were dragged out of the space around the Milky Way and have just become part of the Milky Way, and their outer stars were swallowed up by the Milky Way, but what's left is this tightly packed nucleus of old stars. We know that globular cluster stars are very old, and so what has happened is that the biggest of these things in our sky is a globular cluster called Omega Centauri, and that is in the constellation of Centaurus in the southern sky, one that we see very clearly from here in the southern hemisphere. It's actually one of the reasons why telescopes in the southern hemisphere are important. The two biggest globular clusters are in the southern sky. Scientists have studied the the globular cluster Omega Centauri by putting together a very large number of images, more than 500 images of this cluster taken by the Hubble Space Telescope. And the thing about the Space Telescope is it's very, very accurate in the way it can position the stars. You can look at it and your images will show stars as they are at that moment. But if the stars are moving, if they're circulating around something, then having 500 of them that have been taken over a long period will give you almost like a time-lapse movie of what's going on in Omega Centauri. And what they've done is they've done that and basically revealed a place where stars are moving in such a way that we believe there is an intermediate mass black hole in the middle. So it's it's one of these things where you're actually searching for something, and you're using the right tools, and basically they have found it. That's the current outcome of this research. There's some nice pictures of the center of the globular cluster Omega Centauri taken with the Hubble Space Telescope on the web. They're easy to find. And the nice thing about the story is that whilst the science team were led by scientists from the Max Planck Institute for Astronomy in Germany, there are University of Queensland researchers as well involved with the team. So Australian astronomers are mixed up with this, which is brilliant. And it looks as though this is the first really definitive evidence of an intermediate mass black hole. Now, I hope the next question you're going to ask me, Andrew, is how do they know that it's 20,000 times the mass of the sun?
That was going to be my second question, but yeah, let's go with that.
What was your first one going to be?
I forget. No, it was. No, I'll get to it because what you've brought up is probably a more important aspect of it at the moment. But I'll get to the question I had in mind in a tick. So how do they know it's 20,000 times the mass of our sun?
I thought you'd never ask me that, Andrew. Thank you very much. So if you can detect stars moving around, which is what's happened here, and what you can do is you can say, well, these stars are moving in a gravitational field, and you need several stars to do this. One's not really enough, but if you've got several stars, you can basically track the way they're moving, and from that you can deduce what the sort of center of attraction is. What is the thing that they're moving around? Because they'll be in orbit around something. Everything's in orbit around something, and so that's how you can measure the mass, because once you model their movement, you basically it's very simple mathematics. Actually, it's Kepler's laws, go back to the early 17th century, when Kepler formulated these laws that tell you how things move in a gravitational field. He didn't know it was moving in a gravitational field, but that's what's happening. And so from that, you can deduce how massive the object is at the center. And the answer in this case is 20,000 solar masses. It's exactly how we've measured the mass of Sagittarius A star, the black hole at the center of our own galaxy, because there are stars that you can see actually orbiting that, which have been measured by two different telescopes. Some are the Very Large Telescope, others by the Gemini telescopes in Hawaii. So we've got two independent research groups that have done that work, and we've got this is the work on the center of our own galaxy, and the mass has been measured by this motion of the stars. So it's a really nice piece of research and very exciting for the world of astronomy. So what was your second question?
Well, you mentioned Sagittarius A star, which we've managed to image. And we know that one's at the center of our galaxy. This one they've found is probably the nearest of its kind to Earth, which is a sobering thought. It's not really that far away. What, about 1,000 light years or something?
No, it's 18,000. That was
18,000.
something
I feel better.
Yeah, you feel happy. Yeah, good.
But it's a recent discovery. It's also a rare black hole in terms of size. How many more are floating around in our galaxy? Because we assume most galaxies have a black hole at the center, but you probably answered the question partially in terms of the reference to globular clusters. But if we know how many globular clusters there are, we have a better idea of how many potential black holes there might be. Is that a fair point, or is that just to do with the intermediate size?
Yes, that's the intermediate size. That's right. But you're absolutely right. If a globular cluster is the smoking gun to have a intermediate mass black hole at the center. They may all have one of these black holes at the center. We haven't made that discovery yet. I can't remember the number of globular clusters at the last count. I think it's between 160 and 200, if I remember rightly, associated with our own galaxy. When you look at the Andromeda galaxy, there are many, many more. They've got many more globulars up there. But no, you're right. What that does is it points to the fact that we might have in terms of intermediate mass black holes, we might have a lot of them in our galaxy. We've got a lot of stellar mass black holes as well, and I think the nearest of those is about 1,000 light years away, but that's only 20 times the mass of the sun or something like that. So the question I thought you were going to ask,
which is Fred's way of saying, I'd like to mention this next.
Well, you mentioned that we've imaged the black hole at the center of our galaxy, the Sagittarius A star black hole. I thought you might ask, can we image the intermediate mass black hole at the center
now that they've found a potential location, can they?
Probably not. And the reason, even though it's nearer, so 18,000 light years away compared with 25,000 light years, even though it's nearer, it's much, much smaller. Remember, the Sagittarius A star black hole is 4 million times the mass of the sun. This is 20,000 times the mass of the sun. So its event horizon will be a much smaller diameter. That means it's going to be much, much harder to image. And I suspect with the present level of equipment, certainly we'll never see an image of it.
Okay, so what you're saying is, in universal terms, size matters.
Yeah, it may. Well, that's right, and it may even be. Sorry, just to take a step further, the reason why this black hole is intermediate mass is because it hasn't grown, and it hasn't grown because there's no hydrogen around it to suck in and turn into energy. And basically build the size of the black hole. So it's because what you see with the Event Horizon Telescope, when we look at these supermassive black holes and try and image their event horizon, you're seeing the effects of the accretion disk, the stuff that's whizzing around it and making it glow. And if that's not happening in the Omega Centauri black hole, we're not going to see it. We're never going to see it. It will just be a black hole with nothing to delineate it from its surroundings, apart from the fact that it's pulling stars around. And that's as I said, the smoking gun.
Yes, it's a fabulous discovery, though, because as we've mentioned a few times over the years, we didn't know if these existed, and when we did, well, there aren't that many of them. So finding one in our vicinity is pretty impressive work. Indeed. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson. Let's take a little break from the show to tell you about our sponsor, Incogni. And if you've ever had your information harvested from the World Wide Web, this is the tool for you. Of course, your information is easily available online. We're talking personal information. We're talking addresses, phone numbers, email addresses, even bank details if your protection isn't good enough. This stuff gets harvested and it is sold by data brokers. They sell it to other people who then scam you or other people in your name, which is happening a lot. I've found my information on the dark web on several occasions in recent years and managed to clean it up. But the more I clean it up, the more I have to clean it up because it just keeps going around and around and around. Chances are you regularly get those shonky emails and texts about winning something. That's a common one. Or your mail being lost, the package couldn't be delivered. Could be anything. And of course, there's a link on these very handy emails and texts to help you out. But it's actually the opposite. They are basically hoping you'll fall for it and give them information that will then enable them to scam you to the tune of hundreds or even thousands or, worst case scenario, tens of thousands of dollars. And there's been a lot of cases of that in recent times. In fact, in 2022 alone, the number of scams rose by 41.5% globally. So what is the solution? Well, the solution is you can go online and clear out your personal data by yourself if you've got a couple of years up your sleeve, because that's how long it will take you. And that's not a joke. It will take a couple of years. And when you've done it, of course, other information of yours is already back online. They just keep collecting it regardless. Or you can use a ready-made solution, and that is Incogni. And as a Space Nuts listener, you get a special deal with Incogni at the moment. It is simple. It works in the background. It provides ongoing protection, so you can sit back, relax, and know that Incogni is protecting you from these harvesters and scammers. And all you have to do is create an account, give Incogni permission to work on your behalf, and that's it. Job done. And if you want to check out the pricing, there's a 60% off deal for Space Nuts listeners at the moment. That is fantastic. Just go to incogni.com/spacenuts for more information. That's incogni.com/spacenuts. And look at the pricing for individual plans, or you can get a family and friends plan. Just depends on the circumstances. But at the moment, 60% off the annual individual plan and 60% off the family and friends plan. Check it all out at incogni.com/spacenuts and see what works for you. But peace of mind is probably, something that we all need in this world of data thieves. So check it out today, incogni.com/spacenuts. Now back to the show.
Roger, you're loud and clear here also.
Space Nuts.
Now, Fred, we are going to talk about what spawned life as we know it on Earth, and that was the last universal common ancestor. And the reason this story's come up is because we appear to have started to develop life as we know it much sooner than they thought. I suppose we should start by explaining what Luca is all about.
Yes, so Luca is an acronym for the Last Universal Common Ancestor. I don't know whether you notice a bit of background noise there, Andrew, and that I've gone dark. There is a delightful lady who is pulling the paint off the paint, not the paint, but the paint limitations off our screen. I'm going to show you what she looks like. If you look away.
Hello. Oh, there we go. Yes.
Yeah.
Will she ever know that she just went around the world?
I don't think so. I don't think she will. She's pulling the tape off that keeps the thing. It keeps the paint from spreading where it shouldn't be. I hope she didn't mind that. She's a delightful young woman, so that's fine. What were we talking about? The Last Universal Common Ancestor. Okay, so it's an idea. I mean, and it's well established, and of course, this is of great interest to astrobiologists because the origin of life on Earth is the only model we've got for the origin of life anywhere. And so, if life is going to form on other worlds, we want to understand how that process might happen. And our evolutionary biologists who look at this kind of thing, they are basically putting the steps together to try and understand what is at the root of life. So Luca is, as I said, it is Last Universal Common Ancestor. It's kind of hypothetical in a way, Andrew, because it may not be, it's probably not just one single microbe, but it is probably a lot of them, which are all the same. And they may even have formed those microbial mats that Marnie and I and our tour group were looking at in the Ediacara fossil beds a week or so, not much more than a week ago. Yeah. Microbes are the basic the basic fundamental entities of life, single-celled organisms. So we have really good reason to believe that if you look back far enough, you will come to this Luca, this single-celled organism. It's a category of organisms, if I can put it that way. Now, that then evolved into what we call the tree of life. I looked into this a while ago because I've given talks about it. And I have to say, and I'll preface this with the disclaimer to the people who I know listen to this podcast, who know a lot more about life processes and medicine than I do. I'll preface it by the disclaimer that I know nothing about biology or living organisms, but what I read is of great interest. As I said, I did a talk about Luca and the origins of life, and I don't know whether the audience realised I had no idea what I was talking about, but they clapped at the end and seemed to be fine, you know.
I did that for 40 years on radio. So.
Yeah, you did, yeah. We're still doing it, Andrew. We're still doing it. We haven't found out yet. Okay, so the tree of life, 3 main branches, bacteria, archaea, and eukarya. And the eukarya basically are the eukaryotic, I think, life forms. I think that's the adjective, eukaryotic. And that includes us, pretty well everything that we know. It's plants, animals, and fungi. So all of these are descendants from Luca. Bacteria, the archaea, that's 2 different classes of sort of fairly rudimentary life forms. And the eukarya, which are us and everything around us. You know, I'm looking out at a lawn and trees, going up the rock face behind our house. That's all part of the eukaryotic life.
As is Hugh, because he's a fun guy. Hugh is, because he's a fun guy.
I thought you were going to be nice to Hugh today.
I couldn't help it, because I know he's watching today.
You know, one day you and I are going to be in mid-sentence and the whole thing's going to go blank. And that'll be the end of it.
Or you'll burst in. That's probably what'll happen.
When Hugh pulls the plug. Gosh, we're struggling with this story. I keep getting distracted.
That's all right.
Anyway, and I'm going to read a little quote from a very nice article by Evrim Yazgin, who's a journalist with Cosmos. It's an Australian science journal, very, very well-respected Australian science journal. He's got some very nice sentences in here, so I'm going to quote him. All Luca's descendants share the same amino acids which build proteins in cellular organisms, the same energy, the same basic cellular machinery and DNA used to store information. So understanding Earth's earliest ecosystem and what the environment was like when Luca lived has been a major plank of scientific endeavour. But first, and this is cutting to the chase, and I hope everyone won't mind me quoting this, but it's great. He's written it very well. But first, researchers had to determine how long ago Luca lived. And just an aside from me, you need to know that because you want to know what the geology is telling you that the Earth was like then. You can think about Luca, but you need to know what sort of environment was there. So we did not, let me see. Yeah, so first researchers had to determine how long ago Luca lived. Using genetic information and known time separation between species from the fossil record, scientists have now determined that Luca lived 4.2 billion years ago. And this is the crux of the matter. This is what the surprise is. And I'm quoting again from Evrim's article. We did not expect Luca to be so old within just hundreds of millions of years of the Earth's formation, which, by the way, was 4.57 billion years ago. Says, I said that last bit, but says Sandra Alvarez Carretero from the University of Bristol, UK, co-author of the study published in Nature, Ecology and Evolution. However, our results fit in with modern views on the habitability of early Earth. That's the thing. If you do what they've done, and it's actually similar. It's similar to a process that took place, I think, in the 6th century when and I can't remember his name. That's terrible. He was a monk, effectively, 6th century AD. He worked out the age of the world from biblical accounts just by saying, well, this took that long, this took that long, this took that long, this took that long. And that's how he knew that the world was created 4,000 years ago. So 4000 BC. I've forgotten his name. Doesn't matter. He was Dionysius. That's right. Dionysius. Thank you. Well done. Well done, that man on the Google. Dionysius. So he did exactly this process. He sort of thought about what we knew from the biblical account in terms of when, how long people lived, how often they did stuff, when they did it. And by that, he was able to work out that the Earth was formed. I think he got it accurate to a couple of years, 4004 BC, if I remember rightly, which certain branches of the church still hold that that's when the creation took place. We've got a different story, 30.8 billion years, which comes from slightly different reasoning. But just going back to the Luca story, that's what they've done. And they've looked at the genetic information that tells you the time separation between the way species have evolved from the fossil record. And so now you get this origin of Luca 4.2 billion years ago. And that's really quite remarkable.
It is.
But there's more, which I haven't read about yet. Hang on a minute. Let me see if I can get to it. No, I can't. Oh, wait a minute. Yes, that's right. Here we go. Okay. So this, again, is a quote actually from a University of Bristol professor of phylogenomics, whose name is David Pisanti. David says, our study shows that Luca was a complex organism, not too different from modern prokaryotes, which are part of the modern, bacterial species. But what is really interesting is that it's clear it possessed an early immune system, showing that even by 4.2 billion years ago, our ancestor was engaging in an arms race with viruses. What about that?
Yeah. That's amazing. So, it throws a whole new light on the origin of life as we know it. And speaking of which, and yes. it takes it
right. Okay. Sorry.
Yeah, that's okay. But it takes it back further, and it looks like this started very early in the life of the planet, which is even more staggering. And I suppose that adds a little bit more confidence to the argument that there could have been life on Mars. And I wonder if that's the sort of thing they're looking for with their investigations at the moment, these Luca type of events.
That's right, Luca on Mars. What a interesting thing. I mean, it's always been said that, as soon as we do find any evidence, fossilized or otherwise, of microbial life on Mars, assuming that we do, I don't know whether we will, but if you assume that they do, the first thing that you're going to want to do is look at its genetic sequencing, get down to the molecular level, and you might find that it's got the same ancestry as we have, that it's got the same Luca. And that would be remarkable, because that means that life on the two planets would have had the same origin. And it flourished on Earth because we had the right kind of climate, whereas Mars, being smaller, just went cold and dry, and life probably didn't survive.
Yeah, we had a better bowl of soup.
We did,
basically.
Primordial soup. We had a better
and of course, just to sort of wind this story up, and you did refer to it early on, this also creates the potential for Luca style of life being created in other worlds if the recipe is right. So it opens that door, particularly when you consider how long ago it happened, much sooner than we thought, and that kind of paves the way for the potential for life to get a little bit of a foothold in other worlds if the conditions are perfectly right, or even not perfectly right. They could start to flourish, and then the atmosphere changes and everything goes
bets
cold.
are off.
Yeah. Fascinating stuff. Yes, and you can read all about it on the cosmosmagazine.com website.
Space Nuts.
Now, Fred, to a story that is a little bit concerning, probably a lot concerning, and one that we only spoke about very recently with a piece of space junk from the International Space Station going through a house in Florida in March. Now we've got reports of space junk coming down all over the planet, not in quick succession, but this is starting to become very common, and they're worried that the time will come where somebody becomes a fatality. This is very concerning.
That's correct. Yeah, and the principal, the sort of common theme of the particular bits of space junk that we've spoken about is not so much the Starlink spacecraft, of which there are now, 7,000 or something in orbit, being launched almost at 20 every 2 or 3 days. The main culprit seems to be the trunking of the Crew Dragon space capsule. So Crew Dragon is something that looks a lot like, it's conical. It looks a lot like the old Apollo spacecraft, but Crew Dragon has what's called a cargo trunk that is the cylindrical part that connects the conical capsule to the launch vehicle, because the bits of debris that have been found, and we found them here in Australia, exactly as you mentioned, that stuff that came through the roof in Florida. There's something been found in North Carolina, some stuff that's been found in Canada. And they all seem to have this common theme, that they are bits of the trunking, the trunk that joins the two bits of the spacecraft together, which clearly don't burn up in the atmosphere. And even though everybody said...
When you look at images of it, it is a huge piece of apparatus. I mean, I'm not surprised it doesn't burn up. The thing's as big as a truck.
Well, that's right. I think some of the lumps that have come down have been, very sizable pieces of kit, and they're interesting bits of stuff that are coming down. Things that have been to space are always interesting, but as you say, there's danger associated with that. And what some of the commentators are saying about this is it's only a matter of time before somebody's seriously hurt or killed by falling space junk.
Yes, and even though there are laws in place, the 1972 Liability Convention states that nations are responsible for whatever they put up there and disposing of it. But the problem that has been created now with practically, rocket launches every day or every other day is that when it comes to civilians, it's a different story. And this is the concern is that it won't be long before lawsuits start getting registered due to damage or even death of people on Earth being struck by debris. And we saw that recently in Florida, as we spoke about a few weeks ago. So it is an ongoing concern, and one that seems to be escalating. This is starting to pop up all over the planet, as you mentioned, the most recent being Saskatchewan. And I was amused by the remedy for that. Was found by farmers, and apparently the SpaceX company sent 2 employees in a rented truck to pick the pieces up and paid the farmers for the fragments, which sounds a bit comical, but what if it killed someone? Different story then.
It will,
very
absolutely.
different.
Very different. So
it's I hope it never happens, but with so much stuff going up and coming down and not coming down well, it stands to reason that mathematically, statistically, something terrible is going to happen. Dovetailing into that story, Fred, is a failure with the Falcon 9 Heavy with a launch recently, and this was to deploy 20 Starlink satellites. which they did deploy, but apparently because of the failure, they couldn't get them to a decent enough altitude. So they'll all be lost. This is a bit of a shock because this is a very, very reliable piece of hardware.
Yeah, it's just a standard Falcon 9 rather than the Falcon 9 Heavy. The Falcon 9,
okay.
they've had, it's slightly different. What is it? The number of launches, successful launches, 364 successful launches of the Falcon 9 system, carrying astronauts as well as, various payloads for their commercial clients and thousands of Starlink satellites. The last time there was a problem was an explosion on the launch pad in September 2016. That is getting on for 8 years ago. So it's pretty. It's pretty reliable as a piece of space hardware. And that's what you want when you're sending astronauts up and down using it. So what's happened this time is it was the second stage of the launch vehicle that failed because it had developed a liquid oxygen leak. And so it couldn't carry out a second burn. In other words, you've got what you've got. You've got the first stage, which actually returned quite safely to the drone ship. Probably, yes, I still love you. That's the name of one of them. The others just read the instructions. That it returned. I don't know which one it went to. There's another one too, but it landed safely on the drone ship. Second stage had a burn to separate it from the first stage, but then there was another one to inject the 20 Starlink satellites that it was carrying into their proper orbits, and that failed because of this oxygen leak. And so what happened was the Starlink satellites. Basically, I think 15 of them just came back to Earth. They just burned up. They thought they could save 5 of them by using their own thrusters to increase their orbit, because the orbit that the second stage put these satellites in was unsustainable. Its low point was only 135 kilometers, which is well in the atmosphere, and would cause it to burn up very quickly. They were trying to use the thrusters on 5 of them to lift their orbits and save them, but I don't think that happened.
No,
now,
the story I hear is they just couldn't do it, and they've all been lost, and that's because of that oxygen leak and therefore the booster failure. But I think they only got to an altitude that was half that required to be a success. So they were on a hiding to nothing by the sound of it.
That's correct. Sorry, I'm just answering a phone call on my watch. Talking about the future. Sorry, Andrew, to be distracted there, but the main issue is that there are 2 forthcoming launches as we speak today. We're recording this on the 16th of July. 2 launches. One is a cargo launch, July 19th, but the other is a crewed launch on the 31st of July for a project called Polaris Dawn, which is a private mission. And Polaris Dawn itself is pretty interesting, actually. It's a private human spaceflight mission. It's a billionaire who's funding it. SpaceX will operate it with a Crew Dragon capsule. And it's the first of 3 planned missions. But it's a bit like, do you remember we talked a few weeks ago about the medical details that had come from a private mission called, I think it was Inspiration 4,
yes,
which had medical people on board, and so they were able to give real-time measurements of people's blood pressure and skin temperature, all of that sort of stuff. That provided a wealth of data that we talked about. That's said basically spaceflight. Yes, it knocks you about a bit, but within 3 months of getting back to Earth, you're pretty well back to where you started with. And there was the issue of the telomeres growing. In fact,
that's right.
One of our regular listeners, Heidi de Block, who's a space medic, she commented on texts received from her about that, how interesting that was, the research that came from that inspiration for mission. This is different. It's a different one. It's a different billionaire. It's a different name, Polaris Dawn, but they will do experiments. They'll do, experiments in the flight. So it's a private company, once again, taking flight using a Crew Dragon. Now, that mission must currently be in doubt with the failure of the Falcon 9 launch that we've just been talking about.
Yes, and of course the ongoing issue with the Starliner, Boeing Starliner, and the astronauts that are still on the International Space Station waiting to come back. And all what this does is it kind of underlines how precarious and dangerous space flight is. I know we're taking it for granted more and more these days, but it only needs to be just a slight change in circumstances that could lead to something horrible happening.
Yes.
The fact that it was there were no people on the Falcon 9 that ran into trouble is great news, but as you said, there are missions coming up which will be taking people into space, and if they're going to have a look at what went wrong and see if they can figure it out so they can avoid it in the future. We'll wait and see on that one. And, of course, if you want to chase up those space junk and SpaceX stories, they're at spacedaily.com. That brings us to the end. Fred, thank you very much.
It's a pleasure, Andrew. We've covered a lot of ground today, and I look forward to the next time.
Indeed, which could be very, 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 very soon. Yeah. You never know. Thanks, Fred. We'll see you. Fred Watson, astronomer at large, and thanks to Hugh in the studio who turned up today. I haven't seen him do anything yet, but I'm sure he'll do something later. And from me, Andrew Dunkley, thanks for your company. See you on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.